On the map here, we're looking at a part of the world between China and Pakistan. And if we zoom in, we can see some pretty crazy topo lines here. And that's because we're looking at a really famous mountain called K2. Now, K2 is not quite as high as Mount Everest, but it's considered more dangerous and more difficult to climb, actually. So when mountaineers are planning their route to the top, there's different ways they can get there, different pros and cons, but ultimately their goal is to get to the top. So the same is true when it comes to liquid loading in a gas well. You know, there's different ways to avoid liquid loading with compression, changing the tubing size, but our goal is to increase our production, maximize it, and delay that liquid loading, all right? But there's different ways we can do it. So I want to investigate that today using the Whitson Plus engineering software. By the way, my name's Graham Helfrich. So here in Whitson, we have this nodal analysis option down here. To create our IPR curve, we can just pick a date from the well's history. It'll note what the average reservoir pressure was through the flow material balance we've done, and look at the current rates, the drawdown, and basically create the IPR for the well. Now, this particular well is flowing through casing. They haven't installed any tubing in it yet, and we can see that at this point, the well is liquid loaded. We see the tubing performance curve of the VLP, it's dashed. That's not good, right? So this particular well's at a high casing pressure, about 1300 PSI. So what if we were to reduce the wellhead pressure down to 500 pounds? Okay, that's exactly what we're seeing right here. So dropping the wellhead pressure from 1300 down to 500 pounds is going to increase our rate by almost 1 million cubic feet per day, and we're not going to be liquid loaded anymore. We can see where the line becomes solid and dashed. Okay, so that's one option. Keep the casing, no tubing, but just lower the wellhead pressure. Now, what if we were to install 2 7/8 inch tubing? Well, this is what our outflow curve would look like here, and we delay liquid loading all the way down here. And this is keeping a high wellhead pressure, about 1,300 pounds. So we're not going to liquid load until about 1,600 pounds. And of course, this is because reducing the tubing or the flow path diameter by installing tubing, that means that we need a smaller rate to achieve the velocity required to unload the well. So 2 7/8. What if we lower the wellhead pressure to 500 pounds with 2 7/8 inch tubing? All right, well, we're going to increase our rate here, higher drawdown, and we are going to delay liquid loading even further down to about 1.1 million cubic feet per day. Okay, so now we're comparing 4 scenarios: our current operating condition, liquid loaded and casing, keeping the casing but dropping the wellhead pressure, installing 2 7/8 with a high wellhead pressure, installing 2 7/8 with a low wellhead pressure. All right, I'm going to get rid of these casing scenarios to clean things up here. So this is 2 7/8. What about 2 3/8? Well, let's check it out here. So this is 2 3/8 tubing with high wellhead pressure. And of course, that smaller diameter means we can produce down to a lower rate before we're going to liquid load. And 2 3/8, but with a lower wellhead pressure, 500 pounds, we get this operating condition and our lowest liquid loading rate at just under 1 million cubic feet per day. So just like when we're planning routes to the top of K2, again, our goal is to get to the top. There's lots of different ways we can get there. As production engineers, we also want to consider all of our different routes to delay liquid loading. And the point is that within Whitson software, we can do it really quickly and easily. Thanks for checking it out.